Hello, welcome back to Honors Topics in Physics. Today we're going to be looking at position versus time graphs, which should make a lot of sense after the activities that you did last week. Hopefully it will. So if we have a car and it moves with a constant velocity of 2 meters per second, it starts at 0 meters, and after 1 second it's going to be at the 2 meter mark. And then after another second it'll be at the 4 meter mark. And then after another second it'll be at the 6 meter mark. Now, if I were to go ahead and graph that, and of course remember that the equal spacing means that it's a constant velocity. If I were to go and graph that, so after 1 second we were at 2 meters, and then after 2 seconds we were at 4 meters, and then at 6 seconds we were 3 seconds we were at 6 meters, etc., etc. 4 seconds would be 8 if you just extend the pattern. Okay. So notice that each time that a second passes, we go up 2 meters. So that's because we're moving at a velocity of 2 meters per second. So the spacing is the same, just like on the picture graph. If we were to graph this line, we would get a straight line. A graph of a constant velocity always makes a straight line. So that's something you need to know. On a displacement versus time graph, a straight line means a constant velocity. Write that down. So if we were to put this in motion, we can see that we are moving at a constant velocity. Now if we find the slope of this line, it'd be rise over run. Do not count boxes, folks. I've been seeing people count boxes. That's not what you do. You subtract the data points on the graph. So the rise, in this case, it went 10 meters. Okay, and the run is 5 seconds. So since we started at the origin 0, 0, it's just that. And if I divide that, I'm going to get 2 meters per second. 10 meters divided by 5 seconds gives me 2 meters per second, which we already saw that number, 2 meters per second. So the velocity is 2 meters per second, positive, and the slope is positive 2 meters per second. That's not a coincidence. The slope of a displacement versus time graph is the velocity. That's another thing that's important that you know, so you should know that. The slope of a displacement versus time graph is the velocity. Now, how would the slope change if something moved faster? Okay. Well, the blue car is moving faster, and it's got a steeper slope. A steeper slope means a bigger velocity, so it's moving faster. Okay. So if we calculate this slope, it would be 10 meters divided by 3 seconds, so 3.3 meters per second, not 2 meters per second. Okay. Now if we have a negative velocity, so we're starting at the 7 meter mark. After 1 second we'll be at the 6, and then 5, 4, 3, 2, 1, etc., etc. Okay. And here's my ghost car coming along. Don't forget me. So now we'll graph this motion. So again, each second it's going down a meter. Each second it's going down a meter. Okay. And we would generate a straight line. It's a straight line because it's moving at a constant velocity. And it's sloped downward because it's a negative velocity. Okay, so negative slope means negative velocity, means moving backwards. Okay. Now, what would it look like if the object slowed? So originally we moved 3 meters in the first second, then 2 meters in the second, then 1 meter in the next second, then a half a meter in the next second. So if we graph that, the spacing is going to be different. We're no longer going to get a straight line, but a curve. Okay, and notice that the curve is getting flatter. It's getting more horizontal. The slope is, the steepness is decreasing, and so that's because the spacing that it's increasing by keeps going down. So if the curve gets flatter, that means that it's slowing down. So either way, the more horizontal it gets, the flatter it gets, that means it's slowing down. So what would be the sign on the velocity and the acceleration here? Well, it's moving forward in the positive direction as time passes, which means the velocity is positive. Its displacement is positive. Okay? But it's slowing down, which means the sign has got to be the opposite. So the velocity is negative. Or I'm sorry, the acceleration is negative. If the signs are opposite, it slows down. Okay, what would it look like if the car were to be moving forward and speeding up? Well, the spacing is going to increase, and our curve is going to do this. Okay, so here it's getting steeper. Okay? It starts off a little bit flatter, and then gets steeper and steeper, and that means that it's speeding up. So the steeper the curve, okay, the faster it's moving. So if it gets steeper, it's speeding up. What's the sign on the velocity and the acceleration here? Well, its displacement is still in the positive direction, okay, which means that its velocity is positive. And the fact that it's speeding up means the signs have to be the same on velocity and acceleration. So the velocity and the acceleration have to both be positive. What about this guy? What's the sign on the velocity and the acceleration here? Well, the slope is negative, which means the velocity is negative. Okay, and as time passes, we're moving towards the negative region on the displacement. Okay, we're moving towards 0, and then if this continued, we'd move into the negative. So my velocity is negative. What's the sign on the acceleration? Well, it's not getting steeper or flatter. It's moving at a constant velocity. A straight line means constant velocity. If the velocity is constant, that means the acceleration is 0. So, alright, okay, so you'll need to be able to answer multiple choice questions along these lines, and basically you're going to answer, is it moving forwards, backwards, is it speeding up, slowing down, moving at a constant velocity? The velocity would be positive, negative, or 0, and same for the acceleration. So, it's moving forwards because the slope is positive. It's moving, it's sloped upwards, so it's moving forward. The slope is positive. It is moving at a constant speed because the line is straight. Okay? The velocity is positive because it's moving forwards, and the acceleration is 0 because it's moving at a constant velocity. All right, let's try another one. So pause it and see what you say for these. All right. It's moving backwards because the slope is negative. It's tilted downwards. It's moving at a constant velocity because the line is straight. The velocity is negative because it's moving backwards. And the acceleration is 0 because it's moving at a constant velocity. Here we go. Moving forwards, backwards. So this one is not moving at all. So the velocity is a constant 0. The velocity is 0. And the acceleration is also 0. That was kind of a wonky one. Let's do this one. So moving forward to backwards. Well, it's tilted. Well, go ahead and answer what you think, and I'll go over the answers here. It's tilted forwards. It's tilted up, so it's moving forwards. It's getting steeper. Okay, so that means it's speeding up. Since it's moving forward, the velocity is positive. Since it's speeding up, the sign has got to be the same, so the acceleration is also positive. All right. So get your answers down for this. It is moving forwards because the line is still tilted up. Okay. It is slowing down because the line is getting flatter. Okay. Since it's moving forward, the velocity is positive. And since it's slowing down, the signs have got to be the opposite on velocity and acceleration. So the acceleration is negative. All right, let's try this one. So moving forwards or backwards. So get your answers down. So take a second and write down your answers. Okay. It's moving backwards because the line is sloped downward. It's slowing down because the line is getting flatter. The velocity is negative because it's moving backwards. And because it's slowing down, the signs have got to be opposite, so the acceleration is positive. Okay. So here we're moving, so get your answers down. pause it for a second. All right, so we're moving backwards because the line is tilted down. Okay. It's speeding up because it's getting steeper. The velocity is negative because it's backwards. It's moving backwards. And since it's speeding up, the signs have got to be the same. So the acceleration is also negative. All right. So do worksheet 2.3 as a little bit of a review, and we'll go from there.